and welcome back. My name is Jack B. And as always, thank you for viewing my video. There is a facility in Alaska performing interesting tests on the ionosphere. The program is called the High Frequency Active Auroral Research Program, HAARP. The facility is located in Gakona, Alaska, operated by the University of Alaska Fairbanks. Its primary mission is to study the ionosphere, which is the highest ionized layer of Earth's atmosphere, to improve global communications, radar, navigation systems, and even research deep space planetary defenses. Deep space planetary defenses refer to the ability to prevent large space objects from hitting the Earth. I will cover more on this topic later in this video. The ionosphere is located 50 to 400 miles above Earth. It affects long-distance radio communications, GPS navigation, and satellite operations. The program was originally established by the U.S. military. Ownership was transferred to the University of Alaska Fairbanks in 2015. Researchers from top-tier universities, Los Alamos National Laboratory, and the Naval Research Lab regularly use the facility. HAARP's main tool is the Ionospheric Research Instrument, which is a massive phased array of 180 high-frequency crossed dipole antennas. It transmits radio beams to temporarily excite and heat small specific patches of the ionosphere. Scientists then use diagnostic instruments to observe how these disturbances affect the upper atmosphere and to study space weather. Space weather refers to the environmental conditions in near-Earth space driven by the sun's activity. It involves the continuous flow of charged particles, solar wind, magnetic fields, and intense bursts of radiation that interact with Earth's magnetic field and upper atmosphere. The effects of space weather can be seen as the aurora borealis. When solar particles collide with gases in Earth's magnetic field, they produce glowing light displays. Power grids are also affected. Severe geomagnetic storms can induce electric currents in the ground, causing voltage fluctuations and damaging large power transformers. Satellites and GPS can be damaged. Charged particles can damage onboard electronics, while solar radiation heats the upper atmosphere, causing satellite drag and orbital degradation. Aviation and communications become unreliable and dangerous. Solar flares can cause high-frequency radio blackouts and disrupt satellite communications. Coronal mass ejections allow elevated levels of radiation to penetrate commercial flights at high altitudes. HAARP transmits in the high-frequency band range, specifically between 2.8 and 10 megahertz. The facility uses an array of 180 antennas that can transmit a combined maximum power of 3.6 megawatts. The radio waves interact with free electrons in the ionosphere, increasing their temperature and causing minor perturbation. Scientists use this localized energy to create artificial plasma, stimulate airglow, and study how the ionosphere affects communications and navigation systems. HAARP's goals are to enhance navigation and communications by learning how radio signals are disrupted and suggest mitigations. To advance space weather research. Data helps analyze natural solar interactions and solar radio bursts, contributing to the global understanding of space physics. To increase citizen science and education. All research data is publicly accessible to universities, researchers, and citizen scientists around the world to support collaborative astronomical and atmospheric studies. To understand the needs and parameters for planetary defense, HAARP has transmitted radio signals at passing asteroids to analyze their internal structures and mass distribution. This data helps scientists calculate how to effectively deflect hazardous near-Earth objects. Deep space planetary defense refers to the strategies and technologies used to detect, track, and mitigate the risks of near-Earth objects, such as hazardous asteroids and comets potentially impacting Earth. It relies on early detection and physical deflection to alter an object's orbit before it poses a threat. Detection and tracking is the first line of defense, which requires identifying potentially hazardous space rocks years or decades before an impact. Ground and space-based telescopes continuously scan the sky for moving objects. Observatories feed position data to organizations such as the Near-Earth Object Study, which calculates exact trajectories and impact probabilities. Deflection as a method of mitigation. If a hazardous asteroid is identified to be on a collision course with Earth, then space agencies utilize mitigation methods to push the object off its earthbound trajectory. A kinetic impactor is a high-speed spacecraft that is intended to smash into an asteroid to slightly alter its speed and orbit. NASA successfully tested this method during the 2022 DART Double Asteroid Redirection Test mission. Gravity Tractor is positioning a massive spacecraft near an asteroid. Over time, the gravitational pull between the spacecraft and the asteroid acts as a towing mechanism to subtly nudge the rock's path. Nuclear deflection is a contingency method, not yet tested, that involves detonating a nuclear device near an asteroid. The resulting intense heat would vaporize the surface, creating a rocket-like propulsion effect to push the object away. Global coordination is required because an asteroid impact could affect any part of the globe. Defense operations require international cooperation. NASA's Planetary Defense Coordination Office leads the U.S. efforts, continuously tracking near-Earth objects and coordinating with international bodies such as the United Nations to streamline global response plans. An often asked question is, how big of an object can be deflected? A kinetic impactor can work on objects 500 meters to 1 kilometer in diameter, assuming we have decades of warning time. However, for the more immediate 50 to 150 meter range of potentially hazardous asteroids, a single spacecraft can achieve the necessary orbital nudge. The core principle of a kinetic impact relies on momentum transfer, mass times velocity. In 2022, NASA successfully demonstrated this technique with the Double Asteroid Redirection Test mission. A small asteroid moonlet named Dimorphos, which is roughly 160 meters, 525 feet, across. The 610-kilogram spacecraft hit Dimorphos head-on at about 4 miles per second. The impact altered the asteroid's orbit significantly, shortening the time it took to circle its parent asteroid from nearly 12 hours to 11 hours and 22 minutes. While the technique is proven, there are practical limitations on how large an object we can handle. There are 3 limitations. Number 1, warning time. Deflection requires years or decades. If we discover an asteroid with only weeks of warning, a kinetic impact cannot shift the trajectory enough to avoid a collision. Number 2, asteroid composition. Asteroids are often loose rubble piles held together by gravity rather than solid rock. If an impactor hits a rubble pile, much of the energy is absorbed by crushing the asteroid rather than redirecting it. Number 3, object mass. For objects larger than 1 kilometer for asteroids with very short warning times, a single kinetic impact does not deliver enough mass. In those extreme scenarios, multiple impactors, enhanced kinetic impactors that use collected space rocks or nuclear standoff devices are considered. Because of HAARP's military origins, high-power equipment, and complex scientific goals, in addition to the fact that the facility is now operated by universities and is funded in part by grants from agencies such as the National Science Foundation, it has unfortunately been a massive magnet for conspiracy theories. It is frequently and erroneously blamed on social media for global warming, weather manipulation, earthquakes, and mind control. Scientists consistently point out that the energy injected into the ionosphere by HAARP is a tiny fraction of that which the sun routinely generates. The weather control myth. HAARP is often falsely blamed for creating natural disasters, hurricanes, floods, or droughts. The fact of the matter is that weather occurs in the lower atmosphere. The troposphere, which extends from the surface at the equator up 11 miles and from the surface at the poles up 3.6 miles, and the stratosphere, which extends from the surface up 6 to 31 miles. The stratosphere contains the ozone layer. HAARP's energy interacts with the upper atmosphere and cannot manipulate terrestrial weather. The mind control and earthquake myths. Some conspiracy theorists claim HAARP can control minds and trigger earthquakes. The fact of the matter is the facility's radio waves cannot reach underground to cause seismic activity, nor can they interact with human biology in this way. The effects HAARP causes to the ionosphere are temporary. The effects of its operations are minimal and dissipate completely within seconds or minutes of turning off the transmitters. In summary, no matter how well and transparent a program conducts its work, and no matter the importance of the information gained by that work, there will be people who cast shadows, doubts, and conspiracy theories upon it. Humans will be humans. Well, these are my thoughts for today. And again, whether you agree or disagree, please verify the information presented. Thank you. And until next time, take care and be safe.
No, Kevin. Me na do it.
Ooh.